Hello, everyone. My name is Dima, and I'm a third-year PhD student at UC Berkeley, and I'll be presenting our work on RoSÉ, a platform enabling the pre-silicon full-stack evaluation of robotics SoCs. So to begin, to truly evaluate custom hardware for robotics, it's important to capture these three main components. First, closed-loop feedback within the system, both in terms of how SoC performance can affect robot behavior and the other way around. Secondly, it's important to model full-stack platforms, including both software and hardware, because of the complexity within the robotics pipeline. And finally, it's important to do pre-silicon evaluation to capture the diverse range of architectures that can be designed in a closed-loop setting. So to do this, we enable robotics researchers to accurately evaluate heterogeneous robotics SoCs running in a full software stack in real-world environments. And in doing so, we support accelerator developers, algorithms researchers, and robotic system engineers. So to do this, we present our work on RoSÉ. So this has two components, environment design flow and also a simulation deployment flow. For designing an environment, first we need to create an environment using Unreal Engine, which creates the map and also sensors and actuators for the robot. Secondly, we generate custom hardware to run on this environment using the Chipyard framework. And finally, we build software both using DNN workloads using PyTorch and also classical robotics workloads using the robot operating system ROS. Then we deploy a simulation. This includes an Unreal executable built with AirSim, for instance, to simulate UAVs, a FPGA accelerated RTL simulation using FireSim, which contains both the RTL for the target SoC as well as bridges to synchronize with the rest of the simulation, as well as a Linux image built with FireMarshal containing both classical workloads using ROS and DNN workloads using Onyx runtime built on top of Fedora. Now that I've given a background on the infrastructure, I'll give a demo of how RoSÉ is used in action. On the top, you see a simulation of a UAV flying in the environment, and at the bottom, you see the output from UART from the simulated SoC below. So this SoC is running in-order rocket core as well as a Gemini-based systolic array DNN accelerator, and is completing a trail navigation task. So this way you can really have the closed loop feedback within your system of the actual SoC you would deploy in the real world. So using this infrastructure then, we can then do more advanced hardware software co-design within robotics. For instance, in this workload here, we see that if you have an in-order core or an out-of-order core with Boom, you actually find that different DNN architectures are optimal for control. And so this way, you can do this full stack evaluation within one system. So again, we're excited to listen to this talk. If you're interested, listen to our full talk on Monday, and we'd be glad to welcome new users. Our work is open source, and the results are evaluated using artifact evaluation. So thank you for listening to the talk.